So let's explain how to approximate probabilities. Probability of E is approximately equal to the frequency of E over the number of trials of the experiment. Okay, this approximate symbol, the result is approximate because different trials of the experiment lead to different outcomes. Basically, that means different estimates of the probability of E. Let's look at an example. An insurance agent currently insures 182 teen drivers. Last year, 24 of the teenagers had to file a claim on their auto policy. Based on these results, calculate the probability that a teenager will file a claim on his or her auto policy in a given year. So we're looking for the probability of E. What's the frequency of filing a claim? So E is file a claim. What's the frequency of filing a claim? 24. And the number of trials of the experiment, 182. So we do approximately equal to 0.132. So let's type this out, what this means. So for every 100 insured teenage drivers, we expect about 13 to have a claim on their auto policy. Keyword is about. We cannot say exactly. It is about 13. Let's look at another example. Pass the Pigs is a Milton Bradley game in which pigs are used as dice. Points are earned based on the way the pig lands. There are 6 possible outcomes when one pig is tossed. A class of 52 students rolled 3,939 times. The number of times each outcome occurred is recorded in the table. So we have a total right here, so no need to add these all together. So first, let's look at A. Use the results of the experiment to build a probability model for the way the pig lands. So really, for this probability, we've already done something like this. It was called relative frequency. Remember, you take your frequency and divide by the total. So when you do that, you get 0.341 here, 0.329, 0.195, 0.093, 0.035, and 0.008. So again, we're just taking the frequency of each one and dividing it by the total. Okay, first verify this is a probability model. All these probabilities are between 0 and 1, and they add up to 1. So this is a probability model. What is the probability that a thrown pig lands on the side with the dot? Here's the side with the dot. The probability is 0.329. Or you could write 32.9%. Either one is correct. Would it be unusual to throw a leaning jowler? Okay, so it's not saying the cutoff point. So we're assuming 0.05. Is it less than 0.05? Yes. So it's unusual because it's less than 0.05. There are no impossible events, correct? If I put heads on here, like, that's a bad example. If I put the number 1 on here, like if you rolled a dice, the probability would be 0. So that would be impossible, right? Because when you throw a pig, you can never get 1. Or think of like flipping a coin. You have the options of head or tail. If I said, what's the probability of getting a 1 when you flip a head or a tail? That'd be 0, right? You don't have a side of the dice that's 1, or a side of the coin that is 1. So surveys are probability experiments. Each time a survey is conducted, a different random sample of individuals is selected. Therefore, the results of a survey are likely to be different each time the survey is conducted because different people are included. So this would be an empirical approach.